again, I would suggest that you're not necessarily, I probably shouldn't do them right on here. There's not necessarily room on here. So let me just do it separate. All right, so number 4, we have e to the x plus y plus 3 e to the y equals 10 and y equals x. Okay. So let's start with the substituting part, right? Because I've got to use it as a system, so I'm going to start with substitution is the easiest way, right? Y equals x. So since there's already, you have to kind of make these decisions as you go. Since there's already a y here, I mean, you can substitute x in for both of those. I substituted in, so I just leave that y and put the other y in here. It kind of works out either way, but so I put e to the y plus y, right, plus 3 e to the y equals 10. So this really gives me e to the 2y plus 3 e to the y equals 10. So there's something called, if y'all didn't, I don't think you do this in Algebra 2. Do you do what's called U substitution? All right. So U substitution, that's what I thought it was pretty much a calculus thing, and it is. When I was talking to Miss Bruce, and I told her, because she was up here Thursday and Friday teaching Mr. Ackerman's afternoon classes, I told her that we did this because this was an activity that she suggested. And so we had talked through the factoring part of this with the other one. But she said, well, this is when in calculus we do what's called U substitution. And it sounds way more complicated than it is. This whole E thing makes it look weird, right? We agree with that? And so if we can kind of get away from that, it's not that big of a deal. Isn't e to the 2y just e to the y times e to the y? Because you add your exponents, right? Remember we looked at that? So we want to factor this. What I'm going to do is I'm going to say that u equals e to the y. And I'm going to substitute u substitution. Okay, that's all it means. And you've kind of done this before with other variables and stuff, but u equals e to the y. If that's true, then this becomes u squared plus what? 3u equals 10. So you can substitute or you could leave it, but like this, this makes it look a little less scary at this point. Would you agree? Okay, so is this something that we would know how to handle now? Factoring? Okay, so this gives me u squared plus 3u minus 10 equals 0. So that means this is going to give me u plus 5 and u minus 2. Now you have to remember to substitute back in the end. Yeah. So this means that this is e to the y plus 5 times e to the y minus 2 equals 0. Everybody okay with that so far? So now you solve this just like you do any other quadratic. And that means that I make e to the y plus 5 equal to 0, and e to the y minus 2 equals 0. So e to the y equals negative 5, and e to the y equals 2. Well, to get y, what do I do to get y to the exponent? Natural log of both sides. What happens when I take the natural log of both sides here? You can't do that, right? Because you can't take the natural log of a negative number, so that one's not an answer at all. So I get that when I take the natural log of both sides, I get y equals the natural log of 2. Then I'm going to go substitute that back in. And, well, I just realized I was looking back at what I did. I did it the way complicated way. Because you know what I did? I took that y equals the natural log of 2, and I substituted it in here, and I solved it all out. I was like rocking along. I mean, my math looks, it's all nice and pretty. Makes it look nice, but did I need to do all that? No, x equals y. I didn't even catch myself until just now. I was like, why did I even do that? I don't know. But just for the heck of it, let's do it that way because that is steps that you need to be able to do. I think that's, but you know, just like y'all do, you try to make everything hard. I think I was just like trying to make it harder. I don't know. So let's do it that way. We know what we're supposed to get, right? So let's look at this. We've got e to the x plus the natural log of 2 plus 3 times e to the natural log of 2 equals 10. Okay. So here, e to the natural, e to this, let's just rewrite that. E to the x plus the natural log of 2 plus, well, e to the natural log of 2, what is just this part? Do we know? 2, right? Because when you take the e to the natural log of anything, you just get what that is. So it's 2. So really you just have 2 times 3, we get 6 there, equals 10. You can split this up a couple of different ways. I think that I probably made this even harder, but I can take e to the x plus the natural log of 2 equals 4, right? Now, I can split these two up, but I'm just going to go ahead and leave it because at this point, what can I do to get my exponent out of the exponent? Natural log of both sides, right? If I take the natural log of this, don't I just get what's in the exponent? So I'll get x plus the natural log of 2 equals 4. Oh, the natural log of 4, sorry. Because I got to take the natural log of both sides. So x equals the natural log of 4 minus the natural log of 2. And then the natural log of 4 minus the natural log of 2. So to do your condensing and expanding, when you subtract them, it's just a division, right? So it's really just the natural log of 4 divided by 2. So x equals the natural log of 2. I did all of that unnecessary work. But the process is important because you might have to step through a process like that. We all good with that? All right, so what was harder, solving for x and y or just solving for y when you were trying to, was that solving for y here weird too? Any of you actually do it? Okay, that's okay. I wanted to work through more of these with you. Did you at least attempt it? Okay, so we're going to start with e to the x plus y plus 3e to the y equals 10. And our goal here is to get y by itself, right? You have to remember that your rules about exponents, what this really is here, another way to write that is e to the x times e to the y, right? Because when you multiply things with the same base, you just add the exponents. You with me on that? So I do plus 3e to the y equals 10. So when you look at it this way, it's a little easier to think about what you probably need to do next. What can I do here next? What do you think? Because remember, we're trying to get y by itself. If we were trying to get x by itself, it would make this a whole lot easier. Yeah, can I factor out the e to the y? Does that make sense? Isn't this just being multiplied by both of these? So if I factor this out, e to the y, that gives me e to the x plus 3 equals 10. Everybody understand that factoring part there? Because now I just have y in one term, and that's very helpful. Okay, I still need to get this term by itself before I try and get y by itself, so what do I do next? Divide. Opposite multiplication is division. You agree with that? So I get e to the y equals 10 divided by e to the x plus 3. Now, still got to get y by itself. So I can take the natural log of both sides. Natural log of e to the y is y, and that's equal to the natural log of 10 divided by e to the x plus 3. Now, on this one, when I got to here, and I went and checked my answer, they had it in a different form. And I was like, dang it, because on the first one, we have the natural log of a fraction, and it was okay. So I know I can expand this. I mean, we learned our expanding and condensing rules, but I was lost at first about why we would expand this one and not the other one. And I didn't get a real good answer no matter who I asked. I just said, hey, this is what I think. Do you agree? And everybody's like, yeah, I think so. The problem here is that this is an irrational number, right? Are you allowed to have an irrational number in the denominator? So that's the problem here. The other one that had a fraction, the denominator wasn't an irrational number, so we just left it. Does that make sense? So in order to do this, how do you expand this when it's division? Subtraction. So y equals the natural log of 10 minus the natural log of e to the x plus 3. But in all honesty, even though it's an irrational number in the denominator, the application of this at the calculus level, you don't have to have things simplified all the way. I mean, that's the whole beauty of the AP test. I know along the way we make you do that, but you wouldn't necessarily have to do that. Just make sure you know, the important thing is that you know how and that you know that these are the same, because if this popped up on a multiple choice question and you got this answer, but this was the answer that was there, or vice versa, you need to know that they're the same. Does that make sense to you? Just like the other thing was, because we talked about, because I asked, like, how do we know when to stop, and how do we know when it's okay to just have what we have even though we can simplify it? For instance, if you have the natural log of 8, isn't that the same thing as the natural log of 2 cubed, right? Which is the same thing as 3 times the natural log of 2. Right? All those are equal, just different ways to write them. If you have this, it's okay to stop. You don't have to take it to this point, but you do need to know that they're the same. Does that make sense to you? So you have to know that if you get this and you're like, it's multiple choice and that's not an answer, but this is the same because this is the process to get there. Okay, so recognizing those things are important. But exponents and logs, huge thing in calculus that Mr. Ackerman and Ms. Bruce both said that students are usually a little bit afraid of. So you have to kind of not be afraid of the nastiness. And then, of course, solving the other one for y was very simple. You can't even make that hard. We okay on that? All right. Anybody get partway through one and get stuck or not sure if you're right or have questions on any of them? I would like to give you, how many people even tried number 5? Anybody? Then why don't I want y'all to get started on 5. See if you can solve the system in 5. I'll come around and help you, but I don't want to do everything for you. I will help you through it. I'll work it up here if I need to, but I want to see if you can get it started at least and not be super afraid of it. Okay? Okay. So this was another one where I tried to, I don't know, I just really like making things more difficult than they need to be, I guess. So I went along with just doing what I had done on all the other ones, right? I just took this and knew that this could not be 0, so my domain had to mean that e to the x plus 3 had to be greater than 0, right? So when I went through that, then I get e to the x to be greater than -3, take the natural log of both sides. So that means x has to be greater than the natural log of -3. And then I went, well, you can't take the natural log of -3, so what does that tell me about my domain? Well, it doesn't really, it tells me I need to go back and look at the question again, because there's nothing wrong here, but all I know is that this whole fraction can't be negative, and this can't be 0. Is there anything I could plug in for x that would make this 0? What do you think? I mean, e to the anything. Is it possible to make this right here 0 at all? No. And so there's nothing I can, and I can't make it negative. There's no way I can make this a negative number either to make it a -3. So I can't make the denominator 0. I can't make the denominator negative. So my domain here is just all real numbers. But I still felt like this should tell me something. But nobody can give me a good reason for that. I mean, x is greater than something that's undefined. I guess could mean all real numbers, but that doesn't really make a whole lot of sense either because it's undefined. But this is totally not necessary. And the other one is all real numbers as well. So you just need to kind of analyze that and figure out if it's even possible to make it 0 or negative. Because this doesn't make it, yeah, that would make it 0, but it's impossible to even do. Okay, does that help a little bit? Yes, what you have? Did you solve for one of them? Mm-hmm. Okay, and and that's what Hannah was just saying. There is nothing wrong with that, but she said when she plugs it back in, she gets something really weird. Yeah, so even though it's not wrong. And so I'll try it. I'm going to show you one way to start it, and then I'm going to work it that way and see what happens. Well, I feel like looking at it, makes it look like it would be easier. Not where my brain went, but again, I tend to try and make things more difficult, apparently. So, I don't know. So we have e to the x plus y. Here's what, and I don't know necessarily that it's more difficult, but I want to make sure that you understand how to handle these without always trying to take the natural log of stuff. If I'm going to take this right here, e to the x plus y, right? Isn't that the same as e to the x times e to the y equals 4? Right? Does that make sense to you? Like that, because that's what happens when you add those, right? Everybody okay with that? And then if I take this one, actually, let me go ahead and solve this for y. So e to the y equals 4 over e to the x. Right? So what I'm going to do is I'm going to do substitution, because elimination doesn't really work here. So I'm going to take this first one and I'm solving it for y so that I can substitute it back into the second one. So at this point, can I take the natural log of both sides? Okay, so at this point when I take the natural log of both sides, right, natural log, then I'm going to get y equals the natural log of 4 over e to the x, which I could have written that differently. I just didn't want to lose anybody. And I think I end up probably the same place you already were. Okay, I think I get the same thing. Again, I just made it probably more difficult. The natural log of 4 minus the natural log of e to the x. Yeah, so I get y equals the natural log of 4 minus x, which is what you ended up with, right? So yeah, so you could have just taken the natural log at the beginning, which there's nothing wrong with that, but just make sure you understand how to split this up so that you know how to handle those. So now we're here. So now I'm going to take this, and I'm going to substitute it in right there. So I get e to the 2x minus the natural log of 4 minus x equals 2. So you got to be careful with this, the whole subtraction, and you got two things that you use your parentheses correctly. So I'm going to get e to the what? How many x's? 3x. Think about that. I'm subtracting this, so yeah. That, remember, it's the basic algebra and arithmetic things that messes up more than anything. Minus the natural log of 4 equals 2. Okay, everybody okay with that? So now I'm going to take the natural log of both sides to get my exponent out. So this is going to give me 3x minus the natural log of 4 equals the natural log of 2. Everybody with me? Stop me if I lose you. Okay, so now again, I'm trying to get x by itself, so I'm going to add the natural log of 4 to both sides. So 3x equals the natural log of 2 plus the natural log of 4. Now, when you do this right here, our condensing, what do you actually do with these? Multiply. So this becomes 3x equals the natural log of 8. Okay, and then this is where, to match the answer that I gave you, you would kind of have to go a little bit farther. Of course, we got to solve for x. So if I'm going to solve for x, I'm going to get x equals the natural log of 8 over 3, which is the same as 1/3 times the natural log of 8. Y'all agree with that? It's the same as dividing by 3. What happens to the number in front of the log? It comes up here, bless you, it becomes an exponent, right? So x equals the natural log of the cube root of 8, or 8 to the 1/3 power. What's the cube root of 8? 2. So x equals the natural log of 2. Everybody okay with that? So then take that and substitute it back in. Now let me ask you this. When you substitute it back in, you can't substitute it into this one, right? You can substitute it into this one. Is there anything else you can substitute it into? How about that? Right? Isn't this right here just that one that's reformatted? We just solved for it. So it's a little easier to substitute it back in here. Matter of opinion, but you just substitute it in here and subtract it and then go from there. We're good? All right, so we did number 4, right? I'd already started you on 3. A lot of you had worked through 2. Now remember, there's a few parts to this. You got to go back and solve for y, but guess what? Because I did substitution here, I already solved this one for y. I just got to go back and solve that one for y along the same lines as this, okay? Because they have to be solved for y that has an x in it, right? We're looking for the actual ordered pairs, which I didn't write that as like that on number 4 when we did that, but the ordered pairs, and then you need each equation just solved for y with the variable in it. Okay? Feeling a little bit better about this? Don't let the weird stuff scare you.